Hi guys, and welcome to our very last video of Algebra 1 class. I don't know about you, but I'm super excited that we made it through the school year. I thought for our last video that we should do one more example of each type of dividing problem. One type where we don't have to rationalize, where the radical disappears off the bottom just on its own, and then one type where we do have to rationalize. I know these fraction problems can be a little bit daunting, and we will be practicing them and going over them also during our live class sessions. All right, so let's get started on our last two examples. All right, so we had a list of questions that we were supposed to ask ourselves. And the first question is, do you see any numbers that are perfect squares? I don't see any perfect squares, right? 50 and 2, I don't know the square root of those numbers. But as I'm looking at 50 and 2, I notice that, 50 is divisible by 2. So that's the second question that we usually ask ourselves is, can I simplify my fraction? Are the numbers things that I can divide? And so the answer for this one is yes, I can simplify my fraction. Now, I like to write it as a single radical with a fraction under the whole thing when I want to simplify. It just lets me see it a little bit more clearly. 50 divided by 2 is 25. And we learned earlier this school year how to divide variables. When you're dividing variables, you're subtracting. So I'm going to take my 6 and I'm going to minus my 4. 6 minus 4 is 2. So my x can also simplify into x squared. And so through the process of doing this problem, my fraction bar has completely disappeared. Not only has the radical disappeared off the fraction bar, but like it's not even a fraction anymore. Right now it's a whole number. And I mean, these are perfect squares. So we can take the square root of them just from memory. If that is not working for you, if you're not comfortable taking square roots from memory, you can always do your factor tree, right? So 25 is 5 times 5. And then we can write out the x squared as x times x. And so we have a pair of 5s and we have a pair of x's. So on the outside, we write a 5 and an x. And since I circled everything that was under the radical, there will no longer need to be a radical sign. So if everything gets circled, there's nothing left over, then you don't need a square root sign in your answer anymore. Okay, so this was our first example. And in this example, the fraction kind of rationalized itself, right? There's no radical under the fraction bar. There's not even a fraction anymore. And so we didn't need to do that extra step that we learned yesterday. So in our next example, we will need to do that. All right, so in this problem, again, we're going to go through our 4 questions. Question number 1, do you see any perfect squares? And again, unfortunately, we have to say no. I don't know the square root of 75, and I don't know the square root of 8. Question number 2, can I simplify my fraction? And unfortunately, on this problem, I cannot. 8 is even, but 75 is not even. So I cannot simplify my fraction. Question number 3, can I do a factor tree? And can anybody escape out of that radical? And so I can do a factor tree on both of these numbers. Neither of them are prime. So I went ahead and off to the side, I did a factor tree on 75 and I did a factor tree on 8. And so 75 turns into 3 times 5 times 5. And then 8 turns into 2 times 2 times 2. And I do have pairs of numbers. So I'm going to go ahead and deal with those pairs. So I have a pair of 5s up here. The 5 who gets out, he goes in front of the rad on top of the fraction bar. And then I have a pair of 2s down here. And then the 2 that gets out, it goes in front of the radical, but it does stay on the bottom of the fraction bar. So just make sure that your numbers are staying on the side of the fraction bar where they were originally. Now the 3 on the top and the 2x on the bottom, those do not have any more pairs, so those will need to stay inside. So now we have this. Now I've walked myself through my 3 steps. No perfect squares, couldn't simplify. I looked for pairs and I found some, but unfortunately not everything was part of a pair. Specifically, we're looking at the bottom of the fraction. I do still have stuff underneath the radical on the bottom of the fraction, and I do not want that. To help those get out of the radical, we need to give it a pair. If we have two of them, then they can get out. And so I have one number 2. I'm going to put a second number 2. And I can do the same thing with my variable. I have one letter x. I can put a second letter x. Now, whatever you do to the bottom, you have to do to the top as well. So if I'm going to multiply the bottom by a 2x, I have to multiply the top by a 2x as well. Notice that they're also both underneath square root symbols. So the 2x's are going to go into the square roots that already exist. They do not go to the outside just yet. On the top, I have an outside 5, and I have an inside 3, 2, and x. None of my inside stuff is pairs. That's okay. That's okay. On the bottom, I have an outside 2. I do have a pair of 2's on the inside. One of those will go out and multiply with the 2 that was already out here. And then I also have a pair of x's on the inside. So one of those will go out. And now I've circled everything inside of my radical on my denominator. So I will no longer need a radical in my denominator. For the final answer, make sure that you multiply everything back together. So on top, I multiplied the stuff under the radical. So 3 times 2 gave me that 6. And then on the bottom, I multiplied my 2 2's that were outside of the radical, and that gave me that 4. One last little side note before I sign off for the school year. You cannot simplify a number that's inside of a radical with a number that's outside of a radical. So I know we see like 6 and 4 here, but the 6 is inside and the 4 is not. And so you cannot simplify those. Same thing with the x's. The things that you could try to simplify is the outside 5 and the outside 4, because those are both outside numbers, but 5 and 4 doesn't simplify. So this is my final answer, and that's it for Algebra 1 class.